all right. We've taken a look at how to solve equations involving exponentials by using a logarithm to make our lives simpler, but so far we haven't actually seen where this would apply to us outside of the math class. So I wanted to take a look at a few examples where we get to see that sort of thing happen. So first example coming from the second page of our notes file, again, it's in Moodle, have it there, talks about the demand function for a product given by this exponential equation. So P equals, we've got 3,000 e to the negative q over 3. So P and Q hopefully feel like standard, supply demand type stuff. We've seen them before in the semester. So we're given two separate questions. On the one hand, we're told if we want a demand of 6 units, where do we need to set the price point? That doesn't actually require the logarithm technology for the most part, because you can plug 6 in for Q. I'm leaving that for you to take a look at. Assignment time. So on the other hand, we do need to use this logarithm machinery if we go in the other direction. So assuming that the lowest we can set the price, or the highest we can set the price, I'm again not an economist, I'm a math teacher. If we set the price at $149.40 per unit, how many should we expect to be able to sell? So in this instance, that's going in for P because it's a price. So we have 149.40 equals 3,000 e to the negative q over 3. We got to get q by itself. That's the thing we're after, the quantity demanded. So we're going to take a logarithm to get q out of that exponent, but first we got to get the exponent by itself, the exponential piece by itself. Divide both sides by 3,000. Shazam! I didn't turn into a muscular guy. Bummer. Anyway, so you can work this out to get a number if you like. I'm just going to carry it around. So, as I said in my last video, I'm a little paranoid about round-off errors, so yeah, I tend to just keep entire expressions around at once. You can be judicious in how many decimal places you leave, and you'll be fine. So, take a natural log of both sides. Like we saw last time, natural logarithm is base e. Log base e of e to the something gives us back the something. And now we just need to get q by itself, algebra 1 style. Multiply over the 3, multiply over the negative. You can multiply by -3 to get the whole thing set up. So we got that guy right there. And when we crank that out, since this is a demand thing, it makes sense we can't really make a fractional unit rounding to the nearest guy. We can expect to sell 9 of these things at this price point. I'm hoping this is like on a daily scale or something. Again, I'm not an economist, but this doesn't really seem like a sustainable economy if you're talking about like a time period shorter than a day, because you're talking about revenues of not a lot when you exchange these things. So that's one example. I wanted to take a look at the next one. So again, we're given a demand function here in this next guy. It does involve a logarithm, so you might get worried that it's going to get a little more technical. It's like, because you can't take a logarithm to get rid of a logarithm. At least, hopefully you weren't thinking you could. You can't. But you're given a demand function. They use x instead of q here, I guess because they slipped back into math teacher mode and stopped trying to pretend we were talking about as if we were all economics experts. So P is our price per unit, X is however many units we're expecting to be demanded for sale. So we want to know in this instance, and this is important, we want the revenue at a given production quantity, so 40 in this instance. So note, that's not an R, that's not a revenue, that's a P, that's a price point. Keep that in mind. So hopefully you remember, we calculate R by multiplying price by the quantity that we're selling. So P times X in this instance. So I'm just going to go ahead and write that so I have a revenue expression. Technically, you could work out what the price is when X is 40. The big thing is, if you do that, remember, you've still got to multiply by the number of units you've sold. A lot of students I've found will just, if they plug the number in right here, they call it a day, and that's not really what you're after. So we have 4,000 times 40 up top, 40 plus 10 down below. We've got a 50 living inside that logarithm. You crank out the arithmetic here, and I got $40,899.55. So that should be much more pleasing to your board or whatever than if you forget to multiply by 40 and then this drops back down to a much smaller figure. So yeah, that it also has the benefit of being correct. So that's a couple of economics type examples dealing with demand functions where we use logarithms either directly like this or using them to isolate a variable as we saw in our earlier examples. There's a couple more I'm going to wrap things up with, but I think that's going to work better as its own video. So don't touch that dial. Oh, good grief. Do any of you even know what that means?